Hi team, welcome to a Wild Math Wednesday. Thank you for showing up for your learning. So let's take a look at a new skill that we're going to be developing this semester is working with radicals. All right, let's take a look. What the heck are they? Radicals are irrational numbers. There's no way to express them as fractions, and there's no way to express them as a decimal that stops or ever repeats. They're just random decimally things. They can never be, do that. Radicals are written as like the square root. Ooh, I'm writing in white. Let's not do that. It's hard to see. Uh, like the square root of n, okay? Where n's not a perfect square. If we had a perfect square there, like the square root of 9, we know that's 3, or the square root of 121, we know that's 11. So those are integers. They're not really radicals. They simplified integers. But when they don't simplify integers, we got weird numbers here. Now, we can always give exact values with radicals by simply leaving the answer as a radical instead of approximating as a decimal. In physics, absolutely approximate with a decimal. If you're an architect, I'm pretty sure you're approximating with a decimal. But in math, just leave it as a radical. The square root of 2 is equal to the square root of 2. There's no need to say that's 1.41 yada 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 on for infinity of random looking numbers. Okay, just leave it as a square root of 2. It's much easier. So let's first investigate. You can pause the video here and evaluate the following things on your calculator, like the square root of 4 times the square root of 4, or the square root of 81 times the square root of 81, and so on, and compare the two columns. Okay, did you pause and do it? I hope so. Anyway, I'm about to walk you through it. So square root of 4 times the square root of 4, that's just going to be 2 times 2. That's going to be equal to 4. Cool, that's pretty easy. But how about the square root of 4 times 4 when it's inside there? Well, let's do it with Bedmas. That's going to be the square root of 16, and the square root of 16 happens to be 4. It's the same. Same in both places. Wow. Okay, now let's look at the square root of 81 times square root of 81. Well, that's just 9 times 9, which is 81. That shouldn't surprise us because the square root of something times itself should just be that something, right? So that's not surprising. Let's try this one. 81 times 81 is 561. 6,561. Let's check the square root of 6,561. I bet it's 81. 6,500 and what did I say? 61. Yeah. And I'm going to take the square root of that. It's 81. Okay, cool. So cool, Mr. Jennings. Yeah, this is radical stuff. All right, now the square root of 12 times the square root of 9. Okay, well, the square root of 9, this is just going to be 3 times the square root of 12. Oops. 12, the square root of 12. Okay, 3 times the square root of 12, because that's just 3. Okay, and the square root of 12, what is it? Well, let's go. 3 times root. Oops, I forget. This calculator, I have to do 3 times 12, but the root of it. Okay, equals 3.17. Okay, so this is 31.2 about. 31.2. It's approximately equal to that. Okay, let's try 12 times 9, which is 108. And then try that. What's the square root of 108? Clear. 108. Take the square root. I must have made an error somewhere. Where's my error? 3 times root 12. Yeah? Yeah? Okay, let's take a look. It's fun to watch me flounder, isn't it? 12. I gotta pause the video. Figure this out. Okay, I figured it out. I punched the wrong thing on my calculator. But this is not indeed equal to that. That's 9 times the square root of 12. Okay, so this is 3 times the square root of 12. You can see it up there. It's 10.4. 10.4. And when we did the square root of 108, 108 is written that way, Mr. Jennings. It's also 10.4. Okay, and these ones are the same as well. So we're seeing if I break these radicals up or have them together under the radical, they're equivalent. So I'm going to write a generalized algebraic expression. That's to say square root of a times the square root of b is equal to the square root of a times b. Okay, that's just true. Now, let's keep going. Okay, so we can simplify radicals to create what's called mixed radicals of the form a multiplied by the square root of b, when a is not 1 or -1, and b is non-zero, b is bigger than 0. Okay, and these are called mixed radicals. The a is the coefficient. The square root of b is the radical. That's the radical. The whole thing is called a mixed radical, and b is the radicand. Not a word we use often. Don't memorize it. But you want to know that a is still a coefficient, just the same way like if we have a multiplied by x squared, a is the coefficient of the x squared term. A is the coefficient of a mixed radical as well. And we're going to be using this property to create these mixed radicals. Let's keep going. So let's express these as mixed radicals. The way we do that is we want to spot these factors that are hiding inside that number. What's special about this list of numbers? Oh, it's just the squares. Okay, it's just the squares. So you want to know the squares, and that's going to help you here. So let's say 50. Well, I can write the square root of 50 as the square root of 2 times 25. And if I break that up, that would also be equal to square root of 25 times the square root of 2. That's using this property here. The square root of a times the square root of b is equal to the square root of a times b. Okay, so we're going to use that to break that up a little bit. But I know the square root of 25. It's 5, so this is equal to 5 root 2. And then you can check this on your calculator. This is what you do to convince yourself. 50, take the square root, about 7.1. Okay, 2, take the square root, about 1.4 times 5 equals, 7.1, exactly the same. Okay, so this is just a conversion. We haven't changed that number. We just simplified it into its simplest mixed radical form. Let's take a look at the square root of 27. Well, 27 could be written as 9 times 3. That's equal to 3 root 3. Okay, now let's do a slightly harder one. 180. I can't see any squares hiding in that. What square is in there? I don't know. So if you don't know, get a piece of scratch paper or do this in your head. This is great practice to do these in your head. Do a factor tree in your head. 2, 90. 2, 45. I already see that 2 2's came out. That's a pair of 2's. That's 2 squared. There's at least 4 as a factor in 180. 45, well, that's 3 times 15. 15 is 3 times 5. And there's a pair of factors as well. So I could write this as this is the square root of 2 squared times 3 squared times 5. Okay? And then 2 squared times 3 squared. This confused some of you this morning. If I have 2 times 2 times 3 times 3, that's the same thing as 2 times 3 times 2 times 3 equals 6 squared. So the number that jumps out here will be 6 root 5. Check on your calculator that 6 root 5 is the same thing as the square root of 180. I'm done checking. I'm pretty convinced. So let's keep going. Now, we can add and subtract radicals as well. Just the same way you collect like terms, like you're collecting x's and you're collecting y's. Your oil collects with your oil and your water collects with your water. Okay? So it works the same way as adding and subtracting polynomials, but you can only add like terms, okay? Which are, in this case, like radicals. So expressions can be simplified by adding or subtracting the coefficients of like radicals. If we have root 3 plus, that looks to me like 3 root 3, we will have 4 root 3. It's just like that. Just like collecting x plus 3x equals 4x. It's the same principle. Okay, so let's simplify these. Pause the video, try these two, and then unpause the video and watch me do them. So we're like radicals, he and I. Okay, so here we go. Did you pause? Did you try it yourself? I hope so. Anyway, let's keep going. 9 root 7 minus 3 root 7. Well, that's just 6 root 7, man. I mean, I can show you that I have 9 root 7 minus 3 root 7 equals, factor out the root 7. That would be, geez, if I really don't want to show you this. 9 minus 3 multiplied by root 7. Okay, that's factoring out the 7. Okay, that's 6 root 7. All right, but I don't need to do that. I just add them together. Boom, done. Okay, this one, root 8 and root 18 aren't the same. So maybe you got stuck. But you can do it, and I'll show you how. You got to simplify the radicals first. Root 8, so this is equal to 5 multiplied by the square root of 4 multiplied by the square root of 2 plus, that's root 8, right? Root 4 times root 2 plus 3 times the square root of 9 times the square root of 2. Okay, the square root of 4 and the square root of 9 are known. So that's 5 times 2 times root 2 plus 3 times 3 times root 2. Okay, and then 5 times 2 is 10, 10 root 2. 3 times 3 is 9, 9 root 2. So this is equal to 19 root 2. Yay. Now this is tomorrow's lesson. So if you're watching from home but you're planning on being in class on Thursday, you could watch this tomorrow or you can get ahead. Whoa, sorry, that must have been a real weird noise on the video. Now, when you're multiplying radicals, we're going to use we're basically doing FOIL, okay? And I'll show you some examples. All right, distributive property, okay? Think of like so here's like ideas on commutative property, distributive property, and dissociative property. But let's just assume that we know those and look at some examples. We do this, coefficient times coefficient, multiplied by radical times radical. Okay, so let's take a look. So if we have these, then in this case, we are going to have, this is equal to coefficient times coefficient, because like I can group them in any way I want, right? It's multiplication. Multiplication is commutative, means I can change the order of the things I multiply, and I get the same thing. So this is a chain of multiplication, 2 times root 3 times 3 times root 6. Change the order of the chain into 2 times 3 times root 3 times root 6. Okay, and so that's going to be equal to 6 multiplied by the square root of 18. But we just saw that the square root of 18 contains a square, contains 9. So that means this, I'm going to work horizontally, forgive me. This is going to be 6 multiplied by the square root of 9 multiplied by the square root of 2. This is equal to 6 times root 9 is 18 root 2. 18 root 2. So this expression is equal to 18 root 2. Okay, they're equivalent. All right, let's keep going in another color so that our work is very clear. All right, 2 root 3 times 4 plus 5 root 3. Sometimes your solutions will look like this, where you have like an integer part to the solution and a radical part to the solution, particularly when you're using quadratic formula. Because remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. So the negative b, that might create an integer or a rational number that you're at, and then you're adding or subtracting a radical number from that. So we do get these like mixed radicals that have an integer component added onto a rational component. So this is quite common. When we're doing this, we just use the distributive property here and here. So this is equal to 2 times 4 times root 3. That's this times this. Okay? And then we're going to evaluate that plus 2 times 5 times root 3 times root 3. Okay? So now 2 times 4 times root 3. That's pretty easy. That is 8 root 3 plus 2 times 5 times, well, root 3 times root 3 is just 3. Okay, so this is 2 times 5 times 3. So that is 30. And then I would usually write this 30 plus 8 root 3. I usually put the radical part second. I'm not sure if that's standard or not, but it's my habit. So adopt my habits, and then you will have good math habits, I believe. This one is a little trickier. Here we need to use FOIL. Okay, so just FOIL it. 2 times 2 root 5. This is equal to 2 times 2 times root 2 times root 5. Okay, 2 times negative 3 root 7. This is negative 2 times 3 times root 2 times root 7. Okay, and then do inner terms. So this will be positive. So it'll be positive 3 times 2 times root 3 times root 5. And then this one, this will be negative because there's one negative there. Negative 3 times 3, those are the coefficients multiplied by each other, multiplied by root 3, multiply the radicals together, multiplied by root 7. Okay, now simplify. This is equal to 4 root 10. 4 root 10 minus 6 root 14 plus 6 root 15 minus 9 root 21. I happen to know that 10, 14, 15, and 21, none of them contain a square as a factor. So there's no way to simplify any of these radicals. There's no way to add unlike radicals together. So we done with that problem. And that is the simplified numerical answer to that problem. Yes, it's gross. No, these kinds of expressions are not created often in the math we're going to do, but it's a good example, it's a good practice for your foiling and for working with these radicals. So let's say we have a square-based pyramid. The volume of the pyramid is a 1,089 centimeters cubed. Let's find the exact length of the square base in simplified form. Exact length. Okay, we want to simplify it. So pause the video, try it, and then unpause the video and watch me. Here we go. You just paused and tried it. Great. Good for you. Pat yourself on the back for trying, even if you got it or not. Okay. So recall that the volume of a pyramid is the same thing as the volume of the rectangular prism that's the same height divided by 3. It's a third of the volume of the rectangular prism. Okay. So it's base squared multiplied by height divided by 3. Okay. Now just sub in your knowns. So we know volume, it's 1089 is equal to, well, sub in your height, which is known, which is 9, multiplied by b squared, all over 3. 9 divided by 3 is 3. So I might not even write that because I have limited space. I might just write 3 base squared. But here we are. I have 1089 equals 3b squared. Isolate for b. So I'm going to change color to do my inverse operations, a little habit I have. Divide both sides by 3. This number is indeed divisible by 3. Let's see what we get. We get, doing this in my head for math practice, 3 goes into 10 3 times, leaves 1. Goes into 18 because I left 1, so that becomes 18, not 8. So it goes in 6 times and goes into 9 3 times. So that's the b squared. All right, now we take the square root of both sides, which is another inverse operation. So b squared is equal to 363, square root of 363. Okay, I know that 363 is not divisible by 9, but I can spot a factor in there, 121. Okay, I can see that. Why can I see that and you can't? Maybe you can. Good work. If you can, that's great. I can see that because I'm really familiar with the squares. So I know this is 11 root 3 equals b. Okay, 363, I spot it's divisible by 3. I get 121. That's a square. It's 11 times 11. Okay, so these ones are the ones, that pair of squares can send one of those squares outside the radical. This guy, he had no buddy to help him jailbreak. So this is working on radicals. I have different textbook questions for you in the D2L. So this is where you go to find your textbook questions. In the D2L, you go in here to log into a new window. Isn't technology lovely? There it is. And then here we are Wednesday. Try these questions. Tomorrow, Thursday, try those questions. There's also a new challenge problem that's on the wall in 224. I'll post a picture of it as an announcement to the course home. And I'm also going to be posting a challenge problem set today, which I'll talk about tomorrow, about how you can use that challenge problem set for bonus marks. Okay, everyone. Any questions about this stuff, hit me up by email. Otherwise, come find me in class. And thank you for showing up for your learning. Code word is ostrich. So send me an email with the word ostrich in it, and I know you've seen this video. Bye for now.